All right, we're going to continue with notes. As you can see, the first one is already recorded and live on the calendar. So we're just going to go ahead and continue where we left off, okay? So we're talking about displacement and total distance traveled, and now we're going to kind of see the example problems that are correlated with these concepts, okay? So let's begin with, first, identifying the fact that we are given the velocity function, okay? We are given v of t, otherwise this is our f prime of x. So our velocity function, just a quick review, position we remember is f of x, velocity is f prime of x, and acceleration is f double prime of x, okay? So this particular one right here that we're given, is the velocity function. And what we're going to do is we're going to find the displacement, okay, find the displacement or change in position of the glacier between these two times. Okay, so I have specific times that I'm given, and again, we're looking for displacement. So let's look at the low time of 0 and then the high time of 3.5, and this is in years. Okay, so immediately when I'm given a velocity function of some kind, and I see position, or I see the word total distance traveled, or I see displacement in this case, we're going to go to first fundamental theorem, okay? So it is f prime of x dx, the integral or area underneath the curve is displacement between a and b. And that's equivalent to change in position, which is f of b minus f of a. Okay, so remember a and b are x values, and they're from the interval, like this is x1 and this is x2. Otherwise, least to greatest, lowest to highest. So here's my lowest, here's my highest. So I'm going to set up the equation of from 0 to 3 pi over 2, and it's going to be the integral of the velocity function. So let's find a velocity function. Well, this is it right here that's given to us of cosine of t, and it's going to be dt because we're in respect to t. And this is going to be equivalent to our change in position, again, first fundamental theorem, where we're looking at what is the change in positions between the 3 pi, the final position, minus the initial position. Okay, so this is going to give the final position. It gives the final position. We just have to put it in the function. And this one gives the initial position. Okay, so x1 is the initial position's x value. Initial position. So it'll be f of 3 pi over 2 minus f of 0. Okay, so let's go ahead and find this answer. First of all, we're going to say that if we're looking for displacement, this is all we care about here. Okay, so the change in position. And the way that we're going to get that is to solve, let me go ahead and move it over. We're going to solve this for its integral. Okay, so let me grab this one as well. So let's look at what is the integral of cosine. Well, the integral of cosine, I know it's been a while, is a positive sign. Okay, so this is going to be the sine of t. And it is from 0 to 3 pi over 2. Therefore, this one is f of b minus f of a, which is going to equal this sine at 3 pi over 2 minus the sine of 0. This is the change in position, okay, that fundamental theorem of calculus. So let me go ahead and highlight that of what it matches up to over here on the equation that we started with, okay? So this right here, change in position, is final position minus the initial position. And now you can see we're doing this without the calculator. So the sine of 3 pi over 2, so you go to the unit circle, and sine is the y value, so 3 pi over 2 is right here at 0, -1. So this y value, because it's sine, is going to be a -1. Okay, and then we're going to subtract, so let's subtract the sine value at 0. So at 0 radians, this is 1, 0. And the sign is going to be the y value, which is that 0. So this is going to be a negative 1. So the displacement was negative 1. And we're going to be cognizant of our units of measure, so it's going to be negative 1 inches. Oops. All right, so that will be our answer for that one. Let's go to part B. It says find the distance traveled. So distance traveled is not displacement. Distance traveled is the other concept that we're learning is total distance traveled. So total distance traveled, this is referring to accounting all displacements are positive. Okay, so they're interpreted as being positive displacements. Okay, so let's go ahead and set this up. If it's from 0 to 3 pi over 2, it has the same initial setup, and it's still going to be the velocity function that was given as cosine of t. But the only difference here is that we're going to look at the absolute value of all the pieces. Okay, so where cosine would have been negative as far as below the x-axis, we're going to interpret as being positive so that we can account for all of these being positive as far as the displacements are concerned. Nothing's going to cancel each other out, okay? And we've seen that in slides before as far as in this unit. So let's say that you don't have a graphing calculator, or maybe you forgot what cosine of t looks like. Well, the way we set this up without a calculator is we're going to find the zeros of cosine of t. So imagine like cosine of x is equal to 0. And if I were to ask you, where are the zeros of cosine of x? Where do the zeros occur? And we learned this in pre-calc, okay? And we can kind of refer to a unit circle, if we will. And we want to find when is the x value 0. And we remember here at pi over 2 and 3 pi over 2, that's when my x value is 0, because it's 0, 1, and it's 0, negative 1. Okay, so for this problem, we want to see when is the x value, because x is cosine, y is sine, when is the x value equal to 0? Well, it's right here and right here at these respective points. Okay, so that's going to be x is equal to at pi over 2, because remember, this is the angle. You can think of it as theta as well. You could have said theta is equal to, either way. And the other one's going to be 3 pi over 2. Okay, so in one complete revolution, that's the only time that cosine is equal to 0. So the way we're going to break up this equation now so that we can account for everything being positive and nothing cancels itself out as far as some positive cancel out negative and so on and so forth, we're going to be able to split this up into 2. So we're going to go from 0 to something, and then from that something to the next one. Okay, so we're going to say 0 to this first pi over 2, and then we'll pick up again from pi over 2 all the way to 3 pi over 2. And we don't need these absolute value signs anymore. Once we've found the zeros and we break it up into 2 separate integrals, we don't need those absolute value signs anymore. We can just interpret cosine of t dt and added with cosine of t dt over here. Okay, this is just in case we don't remember what the graph looks like, we can do this algebraically and still get the answer. Okay, we're just breaking it up as far as where the zeros occur, where the x-intercepts are occurring, and then we just break it up and solve each one independently and add them up together. So for this first one, we remember that the integral of cosine is sine. So let me go ahead and write that. So we'll have sine of t. And this one over here is also sine of t. Okay, and here's the difference then in part A. Okay, we're still going to add these together, but whatever they are, like for this first one, it's from 0 to pi over 2, and this one's from pi over 2 to 3 pi over 2. Whatever we end up getting as an answer, positive or negative, we're going to then take the absolute value afterward. Okay, so let me show you what this looks like. Let me go ahead and highlight all of this and kind of make room for myself and move it a little bit here. And let's do the fundamental theorem, basically f of b minus f of a for this first one right here. Okay, so this is going to be sine of pi over 2. Let me move this up just a little bit. Minus the sine of 0. Okay, this is for this first one that we're looking at. Whatever we get as an answer, we're going to then take the absolute value of this, and there's our first displacement that we're going to interpret as all being positive. Okay, so the sine of pi over 2 is 1, and then the sine of 0 is 0. So this one, it didn't matter because I still had a positive 1, but nonetheless, when I took the absolute value, it just remained positive. Okay, but let's look at this other one. This one could possibly dip down into a negative. Let's check it. So we have sine of 3 pi over 2, because it's f of b minus f of a, minus sine of pi over 2. Okay, whatever we get as an answer here for this f of b minus f of a, we're therefore afterwards going to, by hand, take the absolute value of that displacement. Okay, so the sine of 3 pi over 2 is going to be a negative 1. So we'll put negative 1. And it's minus, let me subtract the sine of pi over 2, which is just 1. So right here you see a negative 1 minus 1 is going to be a negative 2. But again, we have to remember, after we get those answers, we're taking the absolute value after that. Okay, so this would be the absolute value of a negative 2, which means it becomes a positive 2. So you have this positive 2 adding with this positive 1 to give me a total distance traveled of a positive, quote unquote, 3. So this one is going to be 3 inches total. Okay, so that's the difference between setting up as far as your original integral, where the total distance traveled will include these absolute values, and we do this process of finding the x-intercepts to break them up into two separate integrals that have these bounds showing where they break off and kind of separate from each other. We solve them, and then after we have solved the f of b minus f of a, then we take the absolute value so that we can get the total distance traveled. All right, and a quick thing that you can do if you wanted to check it with the calculator, let's go to the calculator and let's go ahead and put the integral. And it's going to be from 0 to 3 pi over 2. So we'll say 3 pi, let's go to pi over here, over 2. And it's the absolute value. And the calculator, what it's doing is what we just did all by hand of finding this x-intercept and then breaking it up into two separate integrals. You know, back here, as far as finding this x-intercept, breaking it up into two separate integrals, and then taking the absolute value at the end, this calculator is going to do it all in one shot. So we'll say cosine of t, and then it's in respect to t, and we get 3, just like we got over here as far as 3 inches. Okay, if you don't have that absolute value in there, it does change it to a displacement or change in position where you have something that is interpreted as the negative 1 that we got over here. All right, so let's continue. Our next example we have, it says, is let v of t equal 2t minus 1 be the velocity. Okay, and this is in millimeters per second. Millimeters per second. Of an ant on a blade of grass. So find no calc. Okay, so we're going to find without a calculator. Let's look at the displacement that we have between 0 and 2. Okay, so displacement already we know is going to be fundamental theorem, and it is the change in position. So let's go ahead and begin by setting up our integral of the velocity function, which is given to us as 2t minus 1, and it is in respect to t. And we're going to go from the low value of x of 0 to the high value of x of 2. This right here will give us the displacement. Okay, and from here, it's just a basic integral problem where you're going to antiderive or integrate the 2t minus 1. So it becomes t squared over 2 times this constant multiple rule of 2, so we have t squared, and then it's minus t. This is our integrand, okay? Or sorry, this is our integral. This is our antiderivative that we're going to do that first fundamental theorem of f of b, which in this case is 2 squared, minus 2. This is all f of b. And then we're going to subtract by plugging in 0 into this equation, which would be 0 squared minus 0. This is f of a. And that just zeroes out. So you're going to get 4 minus 2, which you get 2. My units of measure here are millimeters. So we'll have millimeters. And this is what we have. Okay, so again, just like the other one where it was inches per year, this one is millimeters per second. Okay, so remember, I know it's been a while, but millimeters per second is a rate that is the velocity function. So when we take the antiderivative to get that position, the units are represented as far as millimeters. Okay, so over here, we're going to look at f double prime. And if we were to take the derivative there, I just want you to remember what's happening. This will be millimeters per second squared. All right. So now let's go ahead and go to the total distance traveled in part B from 0 to 2. Again, we're doing this without a calculator. So let's find the difference here. First of all, we're going to concentrate on our integrand. Whoops. And we're going to find the zeros that we can break this up into multiple sections. Okay, so we're going to find all zeros first. So 2t minus 1 is equal to 0. 2t is equal to 1. Therefore, t is 1/2. So in this case, we only have 1 0. Okay, so we're going to break this up into 2 integrals. If we had 3 zeros, we'd break it up into 4 integrals. If we had 5 zeros, we'd break it up into 6 integrals. Okay, you're just partitioning it into those appropriate intervals. So let's go ahead and break this up. We're going to start with the original 0 that we had, but this time we're going to stop at 1/2 because we have to set up the other integral that'll start from that 1/2 and carry through all the way to the rest, which is that 2 at the very end. Okay. Again, because we're doing total distance traveled, when we set this up, okay, let me move this down and make some room. When we first set this up, we're going to have the interpretation of from 0 to 2, the absolute value in respect to t of this original 2t minus 1. Okay, and our work without a calculator begins here. So going forward, this is our work without a calculator. We did find the 0. We no longer need the absolute value interpretation, so we can just write it as this. And the same here, we no longer need the absolute value because we're going to take the absolute value at the very end after we have figured out each integral, okay, by hand. So let's go ahead and do that. The first one we are looking at is still, well, we already know the antiderivative. It's t squared minus 2t. So we have t squared minus t for this one, and it's 0 to 1/2. And then we will have it again over here, t squared minus t for this one. And this one's 1/2 to 2. Remember, we will be adding these together, but we have to take the absolute value before we add them together. We don't want it to cancel out because we want the total distance traveled for this one. All right, so we have 1/2 squared is 1/4 minus 1/2. That's that first f of b, minus f of a, which is 0 squared minus 0. That's f of a. Whatever that is, we are going to take the absolute value afterward, and then we're going to add it to this one over here. So 2 squared is 4 minus 2. This is that f of b part. Plug in the 1/2 where t's are at. So now we have 1/4 minus 1/2. All of this is now f of a. And then after that, we're going to go ahead and take the absolute value. And everything added up together is going to give us our final answer. So let's go ahead and do the first one. We have 1/4 minus 1/2 Oops, let me go ahead and write 1/4. And then for the other one, we're going to have 4 minus 2, which is 2. And then it's going to be minus 1/4 minus 1/2. So 1/4 minus 1/2, if I get a common denominator going on, I'm going to have to multiply this one by 2 over 2. So I can do this by hand. So I have 2/4. 1 minus 2 is a negative 1/4. So this right here became a negative 1/4 that when I take the absolute value becomes a positive 1/4. Okay. And then now let's concentrate on this one. This one's going to be 2, which is 4 minus 2, minus this negative 1/4. So I'm adding this together. So it's the same as 2 plus 1/4. Okay, so let me just put that plus symbol there. And if I'm getting common denominators, I know by default this is 1. So I'll multiply by a form of 1 so I can get 8 over 4 so that I get 9/4. So it's going to be 9/4. Okay, so this one we definitely did have to use this absolute value to make this negative 1/4 into a positive. But this one we didn't have to. But I mean, if you take the absolute value, basically it just remains positive. Okay, remember absolute value is that distance from the center, or distance from 0, if you will. So it's making everything positive. So then we have 10/4, otherwise 5/2, or 2.5, what are my units? Millimeters. Okay, so let's go ahead and plug this into the calculator just for practice and kind of to check. Let's go ahead and do menu 1/4 to clear any storage in case we've stored, and menu 1/5. Those are good habits to get into right now with the way you're using the calculator with these concepts. So we have the integral from 0 to 2, and it's 2t minus 1 in respect to t. And our first answer was 2, which is what we got over here with 2 millimeters. Then when I do the total distance traveled, we're going to come over here. Actually, I'll just start it from scratch. We'll do the integral from 0 to 2. And it's the absolute value because we saw total distance traveled or distance traveled. And then we do 2t minus 1. And then we do it in respect to t. And that's how we get our 5/2 that we got from the 10/4 that reduced to 5/2, or 2.5 millimeters. Okay. So let's go ahead and move on to a new concept, the average value of a function. Okay, so this is saying what is the average value of a function? In this case, it's wanting to know the average value of this function. Okay, so if I wanted to ask you, what is your current average as far as on Skyward? I'm looking for the average grade. And this is basically your grade in Skyward. So the way you would interpret this is that you're going to use the equation 1 over b minus a from a to b. And let's say that I had a grade function. Well, that grade function would actually be inputted right here. Okay. And then you would take it in respect to x or t or whatever your input variable is. Okay. That's how you interpret this. You're looking at what is the area over the width. Okay. Let me give you an example. Well, first of all, correlated with first fundamental theorem, we know that displacement is the integral from a to b of the velocity function is the same as f of b minus f of a. Okay, and if I told you to take the average, you're going to divide the area, which is all of this, you're going to divide this by the width. The width is like that delta x, that jump from the lowest x value to the highest x value. So that width right here is the same as, what's the width between a and b? It would be b minus a. Okay, so if this went like from 0 to 3, the width would be 3. If it went from like 5 to 10, the width would be 5 because it's 10 minus 5. If it was 11, it would be 11 minus 5, which is 6. That's the width, basically the delta x jump of that high minus the low. And when I do that over here, this right here is saying that this equation, which is the same right here, is equivalent to that area over the width, okay? And that area is change in position. This is displacement. This is displacement, okay? You should start seeing this kind of, oh, that's what this comes from. This is that change in position, which is displacement, both here and here, and it's the area underneath the graph. Again, that width is the jump of that delta x, and that's going to be simply dividing by that jump. So in this average value function, we are looking at specifically all of this is representing here, and it's the average value of position in this case. So here we go. This is the tricky part. If I'm looking for the average value of position, then position is what I'm looking for. It has to correlate with that position. Because right now, if I were to ask you, what does this look for? Does this look for the average value of position? Or does it look for the average, here we go. Does it look for the average f of x, position? Does it look for the average velocity? Does it look for the average acceleration? Well, whatever function you have in the integrand over here is what it's looking for. So in this case, I'm looking for average velocity, which is the average rate of change, which is exactly this right here. The change in position is the same as the average velocity. So now in calculus, you should see this equation right here, boxed in black. You should see it as the average velocity. And that's because the velocity function is your integrand. And you've been doing average velocity without realizing it, or maybe you do, that the average velocity that you've been doing since Algebra 1 is m. It's y2 minus y1 over x2 minus x1, okay? And that's what you have over here. y2 is here, y1 is here, and it's over this x2 minus x1. So that's average velocity. So in calculus, average velocity, you're going to put the velocity function in the integrand, and it's equivalent to, notice the one level jump, f prime to f. This is going to be the average velocity as far as change in position over that delta x, okay? So if I wanted to know, so that's what we did just now, is this average velocity. But if I wanted to ask you, what is the average acceleration? You're going to do that one of two ways. You would do the integral from a to b of the acceleration function. If you are given the acceleration function and you're interpreting it as calculus, or if you're given two velocity values, it would be f prime of b minus f prime of a over b minus a. Okay, that would be kind of like the algebra, the prior algebra interpretation, because that's correlated with this right here. And the calculus interpretation is going to be right here with the function that you're trying to take the average of being the integrand, because it correlates over here to our setup calculus-wise. Now, I know I have a lot of highlights going on. If you need to rewind, if you need to pause, this is huge as far as the concepts that we are talking about, okay? So let's go ahead and move forward. We're going to do a couple problems before we end this video. Let's go ahead and start with find the average value of this function here. So we want to find the average value of that function. This is like saying, what is the average f of x? So I know prior we did the average velocity in this example here, and we also did the average acceleration. But now on the next slide, we're going to find the average value of f of x. Okay, and again, the reason why we did velocity is because by default, I went to this first fundamental theorem, right here. Let me go ahead and point at it. I went to the average value of that velocity function as an example. But if we remember over here, the average value of a function, let me highlight that. The average value is going to interpret f of x, not f prime, but f of x. So let me change that real quick. If it said velocity, then this thing over here would be f prime. If it said acceleration, then this thing over here would be f double prime. Okay, so let's go ahead and find the average value of this function. We're going to start with saying 1 over b minus a because we want to divide by that jump. So 1 over 3 minus 0 is going to be multiplied with from 0 to 3, whatever it is that we're taking the average of. We're taking the average of f of x. Okay, so because we're taking the average of f of x is going to go in here. Okay, there's not a one level jump up. If we're trying to take the average value of f of x, I got to do f prime. No, it's exactly what you're trying to take. That's what goes into the integrand. So we know that f of x is 1/2 x squared. Okay, then everything else stays the same from 0 to 3. And now it's 1 over 3 dx. And yes, this constant multiple rule can come out as a 1/6, so that we have 0 to 3 x squared dx, which the antiderivative of x squared is x cubed over 3. We're going to multiply constant multiple rule with that 1/6, and we still have the 0 to 3 to contend with. And yes, you can make this 1/18 if you will, however you want to do it, from 0 to 3. In fact, what I would probably do from here is constant multiple rule this 1/3 out. So it's 1/18, and then it's only x cubed. It's just so that I work with this 1/6 or this 1/18 only one time. Okay, so that I would have 1/18 is multiplied with 3 cubed minus 0 cubed. So that's just going to be 3 cubed, which is 27. Whoops. Let me get the pen. And then my answer will equal 27 over 18, which if I divide by 9, I'll have 3 over 2. So the average value is 3/2. So 3/2 is about 1.5, which is about here. So out of all the y values that this graph is, all the way from 0 to 3, this graph has a lot of different y values. It has y values here, 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 like infinite y values that it has, because they're correlated with all of these y values as you go through the graph. And the average of those y values, okay, if you were taking average of your 9 weeks grade, or you're just dividing by the total amount that you've accumulated, will in this case give me a 3/2, which is 1.5. This is how we are finding the average value of this specific function. So let's go ahead and practice with the calculator. And we're going to input it just to make sure that we were good to go. So control divide 1 over b minus a, which was 3 minus 0, is multiplied with the integral from 0 to 3. And then the function will go here as far as 1/2. So we'll say 1/2 x squared. And then it is in respect to x. And there you get your 3/2 or your 1.5. Okay, so let's see. Let's look at the next slide. Yes, the next slide is just showing you the work, and there's the average value. So again, something that I want you to kind of correlate right now with was this equation at the very top. It was the area divided by the width is equal to that, that calculus interpretation. So this area divided by the width is over here, highlighted with all these kind of red lines. That right here is the same of this part right here. Area divided by width is kind of in picture form right there. And it's equivalent to the area underneath the curve divided by the jump, divided by that delta x of the high minus low. So the area underneath the curve, let me highlight it as we go. All this area, okay, is all of this. And if I divide it by, I kind of went a little bit too less. All of this area is what I highlighted over there in gray. And if I divide it by the jump, okay, we're going to say divided by the jump is the same as multiplying by 1 over b minus a. And that is right here and right here. So if I divide that area by the jump, it's the same as this area divided by the width. Okay, so it gives you that same area. Otherwise, you're looking for that average value that it would incur. And again, that average value came from all those dots that I was showing you in gray that show all the y values that happen between 0 and 3. If we divided by 3, the average one, if you were to add them up, all up and divide by how many there were, you would get a 1.5. Okay? All right, so I will save these for the next, actually, I'll do one more on this video. Let's go ahead and do that. Find the average value of f of x on 0 to pi over 2. So this is f of x. And if I'm taking the average value, that's my function that goes inside of the integrand. Everything else is from 0 to pi over 2. And now we're going to go ahead and solve it out. We have negative sine of x at constant multiple, roll that out. It's from 0 to pi over 2. And now we're going to take the antiderivative, which is a negative cosine, because cosine's derivative is negative sine, so I have to have that negative to get to that positive sign. So let me go ahead and write this out. So this is negative cosine. This negative out here is still a constant multiple rule, and it's from 0 to pi over 2. Okay, so I know it's been a minute since we've done this, but this negative cosine is the antiderivative of this sign in here. And these two can constant multiple rule out just to be a positive, so that I have cosine from 0 to pi over 2, which fundamental theorem is going to be cosine of pi over 2 minus the cosine of 0. The cosine of pi over 2 is 0. The cosine at 0 is 1. So this is going to be a negative 1. So the average value of this function on this interval, b minus a, or a to b, is going to be a negative 1. Let's go ahead and check it with our calculator real quick. We're going to have control divide 1 over pi over 2. So let's say pi over 2. It's minus 0. And it's going to be multiplied with the integral from 0 to pi over 2. Oops. Say pi over 2. And it is of negative sine of x. Parentheses, and then dx. And we get this negative 2 over pi. What did I miss here? Oh, I see what I did. I forgot to show that it was 1 over b minus a. So 1 over b minus a. So this would have been over here 1 over b minus a, which is 1 over pi over 2. And I just forgot to multiply all of this by 1 over pi over 2. So 1 divided by pi over 2, like we have written here, is the same as 1 times keep, change, flip. Again, we're doing most of these without a calculator, so we're going to need to multiply that in. So it becomes a negative 2 over pi. This is the average value. All right, so we'll stop there for this video. Again, pause, rewind, do whatever you need to in order to understand it.